أجمعين. This is continuation of section 8.1 and we will study now objective 4. We studied 3 objectives before. What is the definition of a solution and how to solve by substitution and how to solve by addition method. If you need any help, please watch the previous video. Now, for objective 4, identify systems that do not have exactly one ordered pair solutions. So we will talk about systems that do not have one ordered pair solution. In the previous examples, all systems had one solution, one ordered pair solution. So we have 2 other possibilities, as we mentioned in the beginning of the section. We said that for any system of 2 linear equations, we could have exactly one ordered pair, or no solution, or infinitely many solutions. When we have exactly one ordered pair, this means that the 2 lines intersect at one point. So here, this system has one solution. It is the intersection point, this point. That's the solution. While if the 2 lines are parallel, what is the meaning of parallel? They have the same slope. If the 2 lines are parallel, then there will be no solution because there is no intersection point between the 2 parallel lines. So if the 2 lines are parallel, there will be no solution for the system. While if the two equations are the same, so they represent one line, so we say that the line coincide, and here we will have infinitely many solutions. What are the solutions? Set of all points of this line, because this line intersects itself in infinitely many points. All right, so these are the 3 cases. We discussed the first case in the previous lecture. Today we will discuss the other 2 cases. When the linear system has no solution, so solution set is phi, the 2 lines are parallel, we say that it is an inconsistent system. So what is an inconsistent system? System with no solution. If you attempt to solve an inconsistent system by substitution or addition, when you eliminate both variables, you will get a false statement like 0 equals 12. 0 equals 12 is not correct. 0 cannot be equal to 12. So this is a false statement. So when you eliminate, when you use substitution or addition with inconsistent system, you will get something like this. Let us see what happens when we try to solve this system. When solving this system by addition method, we obtain 0 equals to 3. How did we obtain 0 equals to 3? Let us see. Let us find out. Let us solve it by addition method. Try to eliminate x from eliminate x from the 2 equations. So let me multiply the second equation by -3. So we will have what? 12x minus 21y. So this is the first equation without any change. Now multiplying the second equation by -3, we will have -12x plus 21y equals -21. Now if you add 12 minus 12 is 0, -21 plus 21 is 0, so you get 0 in the left hand side, and in the right hand side 24 minus 21 is 3. So when we solve this system by addition, we obtain 0 equals to 3, and this is a false statement. It cannot be true. So the solution set is phi, and the linear system is an inconsistent system. An inconsistent system. If you attempt to solve a system by graphing, if you try to graph these two equations, you will obtain two lines that are parallel. Okay, parallel. Two parallel lines. You will obtain two parallel lines. Two parallel lines. All right. Example, solve this system. What would you like to do? Well, I can do like this. I will divide the first equation by 2. Do something strange this time. I will divide by 2. When I divide by 2, I will have 2x plus 3y equals to 6. Now the first equation, I may divide by 3. I may leave it as it is. I will leave it as it is. So it's 6x plus 9y equals to 12. Now I have 2x and 6x. So if I multiply the first equation by -3, I will eliminate the variable x. So negative 6x negative 9y equals negative 18. And the second equation is 6x plus 9y equals 12. If you add, you get 0 in the left-hand side, negative 6 in the other hand side. This is false statement. So the solution set is phi. Discovery. Show that the graphs of the first equation and the second equation must be parallel lines. How can we show that? These are the two equations, okay? How can you find out that these two lines are parallel? By solving each equation for y. If you solve a linear equation for y, you will have y equals to mx plus b, slope-intercept form. So you will have the slope here. Remember, parallel lines means they have the same slope, but they will have different y-intercepts. So y1 would be m1x plus b1. y2, the second equation when you solve it, would be m2x plus b2. You will find that m1 equals m2, but b1 is not equal to b2. So please do that at home and check this. Another equation, another system. Please solve the system and find out the solution sets. All right. Now, a linear system that has at least one solution, we call it consistent. So inconsistent if there is no solution. If there is one solution or more, this is what we mean by at least one or more. If there is one or more, it would be consistent. So in fact, two systems of these three are consistent. The first one is consistent because we have one solution. The third one is consistent because we have infinitely many solutions, but this type of systems is inconsistent. So inconsistent, only one case. Consistent, we have two cases. Lines that intersect, this is the first case, and lines that coincide. Both represent consistent systems. If the lines coincide, then the consistent system has infinitely many solutions, represented by every point on the line, okay, on the line. The equation in a linear system with infinitely many solutions are called dependent. So if we have infinitely many solutions, we call the equations dependent equations. Dependent means it is in fact the same equation but multiplied by a number, a constant. So if you come to this example, the first equation is solved for y. If you solve the second equation for y, you keep negative 5y here. If you take 15x to the other side, and now if you divide by negative 5, you will have 5 equals, you will have y equals negative 15 over negative 5. This is 3x, and so negative 5y equals negative, plus 10, plus 10 over negative 5, and 10 over negative 5 is negative 2. So you will have 3x minus 2, which is exactly this equation. So in fact, these two equations are the same. All right. He said here, solve the system. How can we solve the system? You have two methods to solve the system. But remember, if the system is dependent, if you have infinitely many solutions, what would happen? You will have a true statement like 10 equals 10. Okay, so for inconsistent systems, we have false statement like 0 equals 12. In dependent systems, we have true statement like 10 equals 10. So if you want to solve the system, you can use substitution or elimination. Since the first equation is solved for y, I will solve this system by substitution. So I will write 15x minus 5. I will replace y in the second equation from the value of y in the first equation. This is equals 10. Now I have one equation in one variable. Okay, 15x minus 5 times 3, this is negative 15x, minus times minus, you will have plus 10 equals 10. 15x minus 15x is 0, and you have 10 equals 10. This is a true statement. This is always true. There is no x disappeared. So if the system is inconsistent or dependent, you will not find x. You will find a true statement like 10 equals 10 or a false statement like 0 equals 10. So if it's a true statement, then I know that it has infinitely many solutions, and the system is dependent. Okay, a nice question. How can I write the solution set of this system? Well, I can write it like this. I can say the solution set consists of all ordered pairs xy such that y equals 3x minus 2. So you write one of the equations here and you put ordered pairs like this. This is the solution set of this system. Any ordered pair that satisfies this equation would be a solution of this system. So we have infinitely many solutions, but only the points of this line, which is infinite. So look to this question. Example 6 has infinitely many solutions. As we said, okay, here we have infinitely many solutions. Does this mean that any ordered pair of numbers is a solution? Any ordered pair is a solution? Of course, no. So what is the solution? If any ordered pair is a solution, we will have just write the solution like this. X belongs to R and Y belongs to R. This means all ordered pairs. But we did not write like this. What did we write? We wrote xy such that y equals 3x minus 2. So there is a condition on these ordered pairs. So it doesn't mean that any ordered pair is a solution. The ordered pair xy must satisfy this equation or this equation because the two equations are the same. So when solving this system by the substitution method, we obtain 10 equals 10. How? So substitute the value of x in the second equation from the first equation. 5 times 3y, 15y plus 10, minus 15y equals 10. 15y minus 15y is 0, and you have 10 equals to 10. A true statement. So the solution set is, what is the solution set? all real numbers such that x equals 3y plus 2. This is how do we write the solution sets. The equations in the system are called dependent. Dependent, okay? If you attempt to solve such a system by graphing, you will obtain two lines that coincide. Coincide, okay? Coincide means the same line. The two lines are coincide. Okay. Now, let us solve this system. Please do it by yourself. It is similar, okay? Also, these are some exercises. Solve by the method of your choice. You choose the method, whether substitution or addition. Identify systems with no solutions and systems with infinitely many solutions using set notation to express their solution sets. Set notation is this one. This is called set notation. When you write like this is called set notation. I will leave this for you. Let us do this one, okay? Or I will leave this for you too, and let me do 41. 41, somehow I think it's harder, okay? Or it is not. I will solve it like this. I will multiply the first equation by 2. So I will get 4x equals 3y plus 4. And the second equation, 4x equals 3 minus 5y. Now 4x equals, so I can say that 3y plus 4 equals 3 minus 5y. You can say that this is substitution. I substituted with 4x with the value of 4x in the first equation in the second equation. So now I have one equation in one variable. If you take 5y to the other side, you will have 3y plus 5y, and here you have 3, and if you bring 4, it would be negative 4. 3 plus 5, y, 8y equals negative 1, so y is negative 1 over 8. So this system has a unique solution. Y is negative 1 over 8. Now you can replace y by negative 1 over 8 and find the value of x, or I can go back to the system, okay, and I will write it like this: 2x minus 3y equals 4, okay, and 4x plus 5y equals to 3. So I wrote it in the form ax plus by equals c. And now I will eliminate y. To eliminate y, I multiply this equation by 5 and this equation by 3. So I will have 10x minus 15y equals 20. And here multiply by 3, 12x plus 15y equals 9. If you add, y would be eliminated. And I'll have 22x equals 29. And the solution is 29 over 22. Try to use the calculator to modify 1 to check the solutions. So x is 29 over 22 and y is negative 1 over 8. That's the solution of this system. Solve each system for x and y, expressing either value in terms of a or b. If necessary, assume that a is not 0, b is not 0. There is no b here. There is only a. So how to solve this system? I have 5ax here and 1ax here. So if you multiply the second equation by negative 5, you will have coefficients that differ in sign. So I will have 5ax plus 4y equals to 17, the first equation as it is. If you multiply the second by negative 5, it would be negative 5ax, negative 35y, and negative 5 times 22 is negative 110. Add when you add 5ax minus 5ax is 0. Negative 35 plus 4, that's negative 31. Negative 110 plus 17, this is negative 93. So if you divide negative 93 by negative 31, you will have 3. So the answer y is 3. Now y is 3. All right. How can I find x? I will use, for example, the second equation. So ax plus 7 times 3, that's 21, equals 22. If you take 22 to the other side, I'll have 22 minus 21, that's 1. So what would be x? X would be 1 over a. So that's the meaning of the question when he said express either value in terms of a or b if necessary. So it's necessary here to express x in terms of a. The solution set of this system would be x is 1 over a, y is 3. So that's the solution of the system and the end of section 8.1. In the coming section, we will be talking about equations in 3 variables.